Hello, ladies and gentlemen. Welcome to Mathematics WTW 124. My name is Dr. Mick Messerschmidt. I am the course coordinator for Mathematics 124. And in this course, we will be continuing our first year journey, laying the foundations for more advanced mathematics that is to come in the second year and the third year and beyond. So before we start, let me just mention, having passed WTW 114, the first semester of mathematics is a prerequisite for registering for WTW 124. If you did not pass WTW 114, then you may not register for WTW 124. If you're unsure about whether or not you should register for WTW 124, then please contact your faculty student advisor. Their contact details are in the study guide, which is available on ClickUp. And while we're on the topic of faculty student advisor, they are there to help you. Please make use of them. So for example, what kind of things can you ask of your faculty student advisor? So for example, if you're having trouble with study skills, then please go see your faculty student advisor. If you're having trouble with time management and general management, getting to everything, if you feel that you are always you're always stressed and you're always running out of time, that means that you have trouble with you might have an issue with time management, and your faculty student advisor might be able to help you. If you have trouble with self-motivation, if you just cannot bring yourself to do your assignments, then please go see your faculty student advisor. If you think that you might need some career advice, please go see your faculty student advisor. Your mommy and your daddy are not career advisors, so they might not give you the correct advice. I am reminded of a case of a student who I could see was a born teacher. And I asked him, what are you studying? And they told me, I'm studying actuarial science. But I actually wanted to study teaching, but everyone told me that I should study actuarial science. So I'm studying actuarial science. Although I could definitely see in his eyes that he wanted to be a teacher. Don't let anyone force you into doing something that you don't want to do. If you don't like actuarial science, then don't do actuarial science. Maybe you do like actuarial science. That's also okay. Actuarial science has this, let's say, very few people let's say in the public know actually what it means, what actuarial science means. All they know is that if you're good at math and you study actuarial science, then you will make a lot of money. That is all that they know about actuarial science. So please don't be influenced by people who don't know what the career actually entails. Point is, if you find that your current direction is not for you, your faculty student advisor can give you sound advice on how to continue. Okay, so let's get back to this course. So first of all, this course, Mathematics WTW 124, it is not hugely difficult, but it does form the basis of formal mathematics that comes in the second year, the third year, and in honors. So this course is aimed at laying the foundation for the higher level mathematics. And for that reason, because we are preparing you for those more advanced courses, we will be very, very strict in this course. So both in your computation and in your presentation, in the way that you write and the way that you explain your computations. That is just as important. So this course is not just about computation, it is about more than computation. It is about using the correct language and using the correct notation. And we will place very great emphasis on those aspects as well. And that is to prepare you for what is to come in the second year and in the third year and in honors and beyond. So we will be very, very strict in this course. Let me also add, that is not because we really want to be purposefully mean and we're just being mean and we're subtracting marks for nothing. That is because we are preparing you for more advanced mathematics, where you will actually need those skills, where those skills become more and more important. So our job is to help you to become competent in those skills, in first of all computation, the computational aspects of mathematics, but also in the language and the notation and the presentation of the computations. So our job is to help you to become competent in those aspects. And our job is to certify that you have demonstrated your competence. Our job has nothing to do with marks. If you're here for marks, you're in the wrong place. What we care about and what you should care about is your competence. Can you demonstrate your competence? If you can do that, then you will have no trouble in this course. If you start thinking, oh, how many marks am I going to get for if I do this? How many marks am I going to get if I do this? Don't think that way. Ask yourself, do I understand the question? Do I understand the theory behind the question? Do I understand all the words, all the definitions of the terminology? If you focus on those basics, then the marks will come for free. Don't worry about the marks. Worry about your competence. Okay. And while on that note, worrying about competence, that is our job. It's very easy to get a degree without being competent, and that is something that we want to avoid. So the University of Pretoria is a world-class university, and that is evidenced by every year from the mathematics department we send or we help students to go abroad to do a master's or a PhD or a postdoc at international universities and some of the best universities in the world. So universities like Princeton and Oxford, Cambridge, etc. Also, we help students to get scholarships if they want to do postgraduate studies abroad. Recently, one of our students got a Fulbright scholarship, of which we're very, very proud. The point is, the University of Pretoria is a world-class university, and these students that go abroad, they can still compete on at the same level as the international students. So that is the level that we are aiming at, and that is the quality of education at the University of Pretoria that we are aiming at. So we are not isolated in the world. We compete with everyone else in the world. So our job is to help you to be as competitive on the worldwide stage as you possibly can be. And don't think that being South African is a disadvantage to you. We are geographically isolated, but you have very similar opportunities to international students at the same level. That is because the internet has made the world very, very small, and that is pretty much all that you need to teach yourself anything that you want to learn. And just for example, there are some very prominent South Africans in very, very advanced scientific projects, leading these scientific projects, worldwide scientific projects. So just a couple of examples. First of all, Professor Loyiso Nonka. He is the Vice President of the International Mathematical Union. That is the organizational body in the world that hands out the Fields Medal. The Fields Medal, very recently awarded. The Fields Medal is the highest honor that a mathematics researcher can, or the most prestigious prize that a mathematics researcher can win. And Professor Nonka is the vice president of the International Mathematical Union. So he's a very, very prominent South African in the scientific community. Then some other examples, Professor Michelle Doherty. She is a physicist working on some of these probes. For example, she worked on the Cassini mission to Saturn, and she's currently working on probes that will go to the moons of Jupiter to see if there's any creepy crawlies on the moons of Jupiter. Also South African, born in KZN, did her undergraduate at the University of KwaZulu-Natal, South African. Professor Frans Pretorius, he's a professor at Princeton University, South African. He's one of the leading scientists in the LIGO observatory that detected gravitational waves that you might have heard of. Professor Roger Dean is actually affiliated to the University of Pretoria. He is one of the scientists involved in imaging of the black holes. You might have seen those images, those kind of orangey images of black holes made recently in the last couple of years. He's actually right here at UP, affiliated to UP, working on that. So don't think that being South African is a disadvantage. You have all the opportunity in the world. As long as you put in the effort, you can achieve anything. But you must put in the effort. Don't think that these people that I mentioned, that they got where they were without putting any effort. Effort is the biggest thing. Put in the effort. Put in the effort. If you don't put in the effort, you will not get anywhere. Okay, let's talk a little bit about how this course will work. So first of all, the course material. So first of all, the study guide and the course notes. They are on ClickUp available. And we are currently printing copies of the course notes. It's very useful for you to have a hard copy of the course notes. We will announce how you can get a hard copy of the course notes in due time. Okay, so that is the study guide and the course material. So those are very important. Please read the study guide very, very carefully. The pass requirements for this course is on there. And also the course content, a brief description of what is important, what is not important is in the study guide, and also information about how to come into contact with your faculty student advisor. That is also on there. Okay, so that is the course material. Then let us talk about the let's say the mode of instruction that we will follow in this course. So we will follow in this course what is called a hybrid model. So what we will do is we will have 4 online lectures per week. They will be presented live. So it is in your interest to watch them as they are being broadcast. They will be broadcast on YouTube. The schedule for that is also available on ClickUp. And on Mondays, we will, Monday afternoons, we will send out an email announcement with all the information that you need for the activities that you should keep up with during the week in question. So keep an eye out for the email announcement on Mondays. So what this email announcement is very, very important. It's very important that you read these announcements very, very carefully. They will have all the information that you need. For example, the lecture schedule for the week, the tutorials for the week, the schedule for the tutorials of the week, the homework that you need to submit for that week, and announcements for any other assessments that you need to pay attention to. So these announcements that will go out on Monday afternoons will have all the information that you need to keep up to date for that week. Okay, and while we are on that, very important, these announcements that we will send out on Mondays, they will also include some homework that you must submit. So these homework problems you are expected to complete, and you are expected to hand in, and you are required to hand in all of these homework problems. So your homework submission must be complete. So you will not get any credit if you leave out any part of your homework. You must complete all questions in your homework. So why is that? We're not trying to be mean. We are trying to get you to do some mathematics. So the homework is the barest minimum that you need to do in this course. This is really the least the least that you need to do to be able to do this course. So if you only do your homework, then you are not getting enough practice and you might not do so well. So the homework, first of all, it's compulsory. You must hand in everything, but you must do extra. The course notes for this course is full of exercises, pages and pages of exercises. If you really want to become competent, then what you should be doing is you should do as many of those exercises as you possibly can. So do pay attention to the exercises in the course notes. Do as many of those exercises as you possibly can. We will force you to do at least a subset of those exercises and as homework and to hand them in. Okay, usually we will not grade the homework. Sometimes we will grade the homework. When we do, we will try to give you feedback on the homework. The homework is not about earning marks. It's not about building a tower of marks. Remember, that is not what we care about. We care about you demonstrating your competence. Part of that is getting feedback on your homework. So if we don't grade the homework, how will you get feedback on the homework? And that is where the tutorials come in. The tutorials are extremely, extremely important that you attend the tutorials. So the tutorials, there will be a number of slots. The schedule will be published on ClickUp. So each tutorial will be 80 minutes long. Importantly, they start in week 2. So that is the week of the 1st of August. So not in the first week of the semester, only from the second week onwards. Just for scheduling purposes, we do ask that you fill in the published form on ClickUp to indicate which tutorial session you would like to attend, just so that we have an idea of the venue sizes and how big the venues we need and if we need to adjust that. So what will we do in the tutorials? The tutorials are there for you to get feedback on the homework. So usually what we will do is we will discuss 1 or 2 of the homework problems, demonstrate them fully, show all the steps. So you will get some of the homework problems you will get for free. You can just copy them down off the board. And the rest of the time is there for you to complete the homework or do extra exercises related to the homework for the week. And our teaching team, members of our teaching team, will be available to help you if you get stuck. So you can raise your hand, you can sit alone, raise your hand, get one-on-one help from a member of our teaching team, or you can work in small groups, working on the homework, and if your group gets stuck, then you can get help from a member of the teaching team. While we are on working in small groups, it can be very, very helpful. However, working together in small groups does not mean that one person does everything and has everyone else copy from them. How to best work in small groups is that if you get stuck, you ask a member of the group, how do I get unstuck here? Once you get it, then you continue on your own. So it is very, very ill-advised to ever copy someone else's work or to allow someone to copy your work. That serves no purpose. And if you are caught doing that, either in the homework or in class tests or anywhere, we will likely refer you for disciplinary action. Do not copy from each other. It is allowed to work together, but work together in a constructive way. It is not constructive to not do all the homework. So that is working in small groups. Let me also say how, or describe to you, how will you get the most out of the tutorials? So you will get the most out of the tutorials if you follow the following, let's say, procedure. So on Mondays, the email updates will go out with the homework for the week. So you will have an entire week to do your homework. As soon as the homework comes out, the suggestion would be to go through the homework problems and to do as many of them as possible. That is on Monday. Maybe you have your tutorial scheduled on Wednesday. So while you're doing your homework on Mondays, you might get stuck on some of these problems. So if you get stuck, identify the problems that you get stuck with, and at your tutorial, do ask a member of the teaching team to help you get unstuck. So the point is, you will get the most out of the tutorials if you are prepared for the tutorials. If you have already completed, let's say, all the easy exercises, all the homework problems that you are able to do on your own, and you bring the work that you are stuck with to the tutorials. And it is likely that maybe some of the harder problems we will discuss during the tutorials, so you will automatically gain something from the tutorials. Point is, you must be prepared for the tutorials. And of course, there are pages and pages of exercises in the course notes. If you complete your homework, go through those exercises. There are some more advanced exercises in there, which are very, very useful for you to complete as well if you manage to finish your homework. If you manage to finish your homework, don't twiddle your thumbs in the tutorials, please. Please do as many of the exercises as possible, and do the ones that you don't know how to do. So usually the exercises are, you read the exercise and you see, and you immediately see, I know exactly what to do with this one. You can do that for practice, but there will also be exercises that you read as like, I have no idea where to start here. Those are the ones where you learn the most from. So do as many of the exercises as possible. So that is the tutorials. From time to time, we will write class tests in the tutorials. These will definitely be graded. This is part of the assessment where we are assured that it is your own work. Those will definitely be graded. You will get some feedback on those. So make sure that you are there in your tutorial group writing the class test. The class test will be announced in the weekly email updates on Monday afternoons. Okay, then the tutorials are not the only place where you can get help. So say, for example, you do your homework, you don't quite finish by your tutorial, and let's say on Thursday afternoon you are still stuck on a problem. How do you then get help? So in this course we will use Discord as our main online forum. So if you need any help outside of the tutorials for your exercises or homework, then Discord is the place to ask for help. And we do ask that you ask your question publicly on Discord. Please don't send private messages to the teaching team. Please ask your question publicly. And Discord is purely for questions on the course content. So specifically, for example, if you're stuck with your homework, Discord is the place to ask the question. And what is the reason that we prefer that you ask your question publicly on Discord? That is because it's quite likely that the question that you're asking, you're not the only person stuck on that question. So it is very useful to have this public discussion so that other people, other students, other fellow students who are also stuck on the same problem can see the discussion happening. So that is why we kindly ask that you post your question publicly. Also, we must ask you to please be very, very specific. If you ask a question on Discord, it's not really helpful if you say, I don't understand question 3.5. Please be specific in what you do not understand. So always try first. A better way to ask a question on Discord would be to say, I'm having trouble with exercise 3.5.9. Here is what I've tried. I've labeled this step number A. I'm stuck factorizing this polynomial. I did check all my calculations beforehand. I'm pretty sure that they are correct, but this polynomial doesn't really, I can't see how to factorize it. That is where I'm stuck. Can someone please help me with that? So that is what we mean to be, please be specific about where you get stuck. Again, it's not really helpful if you say, I don't understand question 3.1.5. Find out exactly what where the lack of understanding comes from, and ask specifically what around what you don't understand or where you get stuck. So some advice would be, you very often, if you don't understand a question, it means that there is some terminology that you don't understand. There is a word that you don't understand the meaning of. So the suggestion would then be to page back in the relevant section to find the definition of the word that you do not understand or that is blocking you. So make sure you understand every single word in the question. Once you understand every single word, then try again to understand the question. So it is very important that you learn how to articulate your question. It's okay to be stuck, but you must be able to articulate exactly where you get stuck. And very often that will require some work from you. Page back in the course notes, find the word that you do not understand, or very often there is a very similar example done in the course notes. So try to find an example, the example in the course notes that is related to the question that you are stuck with. So please be specific when you are asking questions. Especially on Discord when we are interacting by text. And it's very, very helpful to send a picture of your attempt at the question. Please don't be shy. Please don't be scared of making mistakes. Mistakes is how we learn. So definitely that is very strongly encouraged to try, even if we make mistakes. Okay, so that is Discord. And Also on Discord, it is also sometimes fun to have some off-topic discussion. If you find something interesting on the internet, a pretty video on YouTube, maybe a number file video or some numerical demonstration or something. There is also some sections to have some fun on Discord, and it really is nice to build a nice community around our course and to get a sense of camaraderie in the course. We are all in this together. Okay, so that is just the preliminary information. So before we end this, let's actually discuss what we're going to be doing in this course. So for that, I need to change over here. Okay, so here I've got the contents of the course notes. So we are very privileged. These course notes were written especially for this course. So we will start on page 1 and we will end on the last page. So we will go through it in that exact order. So that is very nice. Actually, it gives us a nice, let's say, linear progression as we go through the course. We just take it from the top and we end at the end. Okay, so we will start on Monday with chapter 1. And the chapter is called Vectors and a Model for Space. So we will, in this chapter, we will start discussing what we call algebraic vectors, and we will see how we can describe certain structures in, let's say, in 2 or 3 or even higher dimensional space. And this is very important. So for example, in computer graphics, this chapter actually forms a large part of the, let's say, mathematical basis of computer graphics. And it is very useful to visualize things. If you want to play around, there's this piece of software called GeoGebra. And almost everything that we will do in this chapter, we can visualize nicely in GeoGebra. If time allows, then we will do some visualization. So we see here we have a line in 3-dimensional space as I'm rotating it. And we will learn how to make descriptions like this. And if you like to play first-person shooters, this is, if you look closely, a lot of it is just lines and planes and projecting that on a flat screen. That's all that it is. So that makes it quite interesting, actually. So that is chapter 1, and here you see lines in space and planes in space, and we will learn all the tools that we need to be able to mathematically describe these structures. Then we will move on to chapter 2. Those are matrices and systems of linear equations. So there we will learn how to solve systems of linear equations. So systems of linear equations, they come up all over the place. So it is one of the most basic things in mathematics. And we will learn some of the algorithms to solve systems of linear equations. And we will see some applications. Here we see an application to integration. So we will use systems of linear equations. Specifically, we will learn how to integrate rational functions. Then, chapter 3, we will move on to the definition of a limit. So this will be the formal definition of the limit um, that has been standardized and is the definition that we will use from this course onwards. And I will say that this chapter 3, is probably the most difficult chapter in the course. That is because these concepts, the formal definition of a limit, students tend to have a lot of trouble with coming to grips with formal mathematics. And let me also add here, it is not, if you are one of those students having trouble coming to grips with such formal mathematics, it is not just you. If you Google for these kinds of things online, you will see lots of wailing and gnashing of teeth of students all over the world. This stuff is difficult. But if you actually get it, then it can be a lot of fun. And we will do our utmost, our very best to help you to actually have it click for you. Then after chapter 3, we will go on to integration and some applications. So this will mostly be algorithmic techniques of integration. We will discuss the fundamental theorem of calculus, which you have been working with without knowing it. So we will discuss the fundamental theorem of calculus, and we will actually prove the fundamental theorem of calculus. And we will look at some applications of integration. So for example, how to compute the lengths of curves, things like that. And also, very importantly, we will discuss Taylor polynomials. So Taylor polynomials, they are a method for approximating well-known functions. And this is actually how a computer or your calculator actually works out. If you say the sine of 3.9943, in your calculator there's actually a little chip that actually works out the Taylor polynomial to actually give you a value for the sine of whatever value you give it, and that's how your calculator knows what the sine of angles are if they're not special angles. So we will study the theoretical basis of how your calculator actually works out trigonometric functions. Then we will move on to chapter 5. We will discuss vector functions, the limits and continuity of vector functions, the differentiation of vector functions, and curve sketching. So that is also a fun part of the course, and is also very, very important, for example, in physics, in classical mechanics. A lot of things in classical mechanics involve curves in two-dimensional or three-dimensional space. Then in chapter 6 we will discuss complex numbers. So the one of the roots of -1. And you might think that that is made up nonsense. However, one of the most accurate scientific theories ever devised, quantum mechanics, it is very, very accurate in making predictions, has complex numbers in it. There's a little I, the square root of -1, occurring in the Schrödinger equation. So here I've just got the Wikipedia page for the Schrödinger equation, and we see here baked into the fabric of reality are complex numbers. So especially if you're doing physics, complex numbers, very, very useful in physics. So we will study complex numbers, so the basics of complex numbers, very important, the polar form of complex numbers and de Moivre's theorem. And we will discuss some other things about complex numbers. Coincidentally, the profile picture that we use in this course has to do with the roots of complex numbers. Maybe try and figure out how the profile picture of this that we use in this course is related to roots of complex numbers. And then finally, chapter 7, we will look at polynomials with coefficients that are real numbers or coefficients that are complex numbers. And we will learn some techniques in finding the roots of such polynomials. So these polynomials, they can be of higher degree, up to degree 5, 6, 7, 8, 9, 10. We will learn some techniques in finding the roots of these polynomials. And that is chapter 7. That will keep us busy for this semester. Okay, so let me change back to my face. There we go. I'm very much looking forward to spending this semester with you. As we go on, you will meet the other members of our teaching team. That is Dr. Yash Madonna, Dr. Chris Schranke, and Miss Baphumelele Nkala, Miss Hanli Venter. So those are the core members of the team. We might get some more assistants and assistant lecturers. You might meet them as well. As we go through this semester, you will meet those members of the team. So I will see you bright and early on Monday for our first lecture, where we will start with chapter 1 on algebraic vectors and vector algebra. And I'm looking forward to meeting all of you online and luckily face-to-face as well. So best of luck for the semester. This is probably not the only course that you're taking. You're probably taking some other courses. Good luck with those courses as well. Okay, then I will see you on Monday. Bye-bye. I will see you in the next one.